So this overturning force is Pw. So let us understand it by one figure. So it is, let us consider it as a gravity dam. So the water pressure is acting on upstream side. So on upstream side, up to this water is present. So this water pressure distribution diagram for this portion is looks like this triangular. So this is water pressure distribution diagram. So the intensity of this water pressure at base is gamma W, or we can say gamma into HW, that is this height is HW. So the total pressure that is acting at on dam body, that will be your capital P, and it will be acting at this height, that is HW by 3. So this total pressure P will be equal to area of this triangular portion, that is 1 by 2 gamma W into HW into HW. So by using this we can get this pressure. So now based on this, what is moment, overturning moment? So this force P try to overturn this dam by this point. That point is known as a toe. So this force P try to overturn this dam about the toy. So the moment generate about the toy, that will be overturning moment. So here in this case, overturning moment will be equal to moment generated, and that will be equal to this force P, that is 1 by 2 gamma W HW square, and acting at a height HW by 3. So by this we can find out this overturning moment. This force is resisted by the weight of dam. So weight of dam will generate resisting moment. So let's understood it. And try to draw another figure. Okay, so let's understood this weight. So the weight is acting at this point. So the CG from this is x bar, let's say, and this distance that we need to find out. So the total width is b. So this distance will becomes b minus x bar. So this force W will generate resisting moment, anti-clockwise moment. So this force generates the resisting moment. So let's try to form the equation for, so it will be resisting moment. That will be equal to, this force is W weight into distance from toe. So from this is toe and the distance will be b minus x bar. So it will becomes b minus x bar. So this is the resisting moment. Okay. So now let's find factor of safety. So factor of safety, that will be equal to whatever the resisting moment divide it by disturbing moment, or we can say overturning moment. So we get the factor of safety as force P into HW divided by 3, and here W, it will be resisting moment will be a W into B minus X bar divided by force P into HW divided by 3. We can put the equation for P in this equation. This factor of safety must be greater than or equal to 1.55 for safety against overturning, or we can say for safety in overturning. So it's a second criteria for the stability of the dam. So let's move forward. Third one criteria is excessive compressive stress. If the stress generated exceed the resisting force, so it will be a material strength. If it is a concrete dam, then compressive strength of the material, that is concrete. So this compressive stress shall not exceed the material strength, compressive strength of the material. Then it will be a safe in a compression. And as we all know, concrete cannot take a tension. Dam should be a safe in a tension also. So for that purpose, there will be a no tensile stress generated in the dam. So minimum eccentricity criteria needs to be satisfied, or we can say sigma minimum should be greater than or equal to 0. So this criteria needs to be followed during the analysis of the dam. So what today we have seen? Today we have seen the stability analysis for the gravity dam. For this we need to check the 4 criteria. Which 4 criteria that we will see? First one, we have seen the criteria for the sliding. Second one, we have seen criteria for overturning. Third one, we have seen criteria for compressive stress, and fourth we have seen criteria for the tensile stress. So let's make it. So what today we have seen? The stability criteria for the dam. In that we have seen 4 criteria. First one, that is safety in sliding. Second, we have seen safety in overturning. Third one, we have seen compressive stress, safety against this compressive stress. Fourth one, we have seen safety against tensile stress. So that 4 thing today we have seen in this module. So in that criteria, what we need to kept in our mind? So we have to keep these things in our mind. That so let's again, I will draw this figure for the dam. So here it is a dam. Water will be up to this level, so there will be the water pressure on this side. The weight is acting at this side. Just we have to keep these 2 things in mind. First one is a water pressure P, and second one is a weight W. If we understand these 2 points, then we can easily solve the question example based on these 2 points that we will see in next lecture. Various example based on these topics.